All right, we're making it through. This is going to be a short one, believe it or not. Explore number 5. Let's go and write down our essential question here. How does the law of universal gravitation, sorry about that, apply to objects near Earth's surface. Go ahead and hit pause. Tell me what you know or think. All right, hopefully you wrote down something that you know or think. Roman number 1, objects near Earth's surface. So, we've talked about this, and you can take a look at these first couple paragraphs here in the text. The law of universal gravitation states that spherical, that means round, objects act as though their masses are concentrated at the center. So I guess we could draw that. A spherical object, gravity is going to be directed towards the center of the mass. Okay, the force of gravity is towards the center of the mass. Since Earth is approximately spherical, I don't want to say it's a perfect sphere, objects on its surface are pulled by gravity towards the center. Remember that the strength of gravity is lower when objects are far apart. The change in distance, this is important here. The change in distance must be relatively large to see any appreciable effect. Just because you go from sea level, you're at the beach, and then you go and climb a mountain that's 10,000 feet high, that's not an appreciable increase. You're not going to really notice a big change in the gravity. But, if you're on the International Space Station versus on the beach, now you're starting to get to an appreciable difference in distance, and you're going to sense a change in the gravitational force. That's what they're trying to say here. Okay. Watch this on Felix Baumgartner. He was for Red Bull. He did that record-breaking dive from the stratosphere, and pretty phenomenal. Anyway, they go into his spacesuit and everything. So anyway, let's talk about this equation. For objects near Earth's surface, the force of gravity equals the mass times the gravitational force. This is very similar to this equation that we had done earlier. Force equals mass times acceleration. Now, for objects, let's go ahead and put a little star here. For objects near Earth's surface, dot, dot, dot. We could, in essence, write this equation as the force of gravity is the mass times the gravitational constant, okay, which would be, in this case, 9.8 meters per second squared. Okay, this is only for objects that are near Earth's surface. Okay, so force equals mass times acceleration. Where you are close to Earth, we can substitute acceleration for 9.8 meters per second squared. And I imagine in this particular case, we could say in this case, we could say that A is equal to G. Okay. Boy, there's really not a whole lot to say here. Read the text, watch some of the videos, and look through some of the work problems that they provide here for you. But boy, we've been working through these problems, and this is pretty straightforward here. So again, I guess if we were to write maybe some margin notes to ourselves, we could say that this is Newton's second law. Right? F equals ma. And when you're solving for objects near Earth's surface, you can substitute acceleration for 9.8 meters per second squared. Here, m is the object's mass, g is acceleration due to gravity. So I guess that's g is the acceleration due to gravity. Okay, so maybe we can write that down here, okay? G equals the acceleration due to gravity. All right, well, I think that really is it. Told you this was going to be a short one, so go ahead and write down a summary paragraph. And we'll talk to you soon.